Welcome. It's a new function. Big text. So I'm still looking for AI. And I'm doing the basic stuff like tokenization. Like say you have this input and there's different ways to split it into individual tokens. Token is just a word. You can, if there are brackets, you can group these. See, this is one piece, or you can leave them as individual pieces. And the gray parts are like the white space, that's stuff you ignore. The comma is either ignored or is seen as its own token. Similar with the period here. So this is all the legwork, the base work for textual AI. And if you know me, I'm sure you know me, you know I always look for other algorithms too, like for image recognition. I really love image recognition. And the point is that it can be done in new ways. There really are unexplored ways. There's a whole universe of unexplored ways to do image recognition. For example, recognizing stuff on the screen. Like just the basic stuff. Computers don't understand their own screen contents. Like they actually really don't understand. They just produce it, but they don't analyze it. Let's say we want to find like this title bar up here and whatever this taskbar down here. Surely that's useful. And I want a simple and understandable algorithm. So what do? We make some grid, like some slices. We take 8 pixels vertically at a time. Just to get some grouping. We don't want to look at each individual line, that makes no sense. So if we make slices that are 8 pixels high, we get something like this. So the black is just the spacing. So basically we dragged the screen contents apart into these slices. And then we look at the dominant color in each slice. And also we just reduce the number of colors first, because nowadays things are like, there are shadings and graphics are a little more fancy than they used to be. So we reduce everything to 256 colors. I came up with this artificially. It's 332, 3 bits for red, 3 bits for green, and 2 bits for blue. Because the human eye is most receptive to green. So we have 8 bits, I wanted to use 8 bits. So with 3 colors, 1 color had to lose out. So green lost with 2 bytes, the other colors get 3 bytes, whatever. We just reduce the colors a bit. And I can show you the reduced colors again. And then we make a simple search. For each line we look at what the dominant color is. Here, this is the reduced version. Most of the time you don't even notice, but of course with graphical stuff you see that there are less colors. Well, this is better for recognition. And then we just look at how long the color repeats. If we have 3 slices which are blue dominantly, we say this is the title, and then maybe white comes or gray, and that's the break for us. It's a pretty simple algorithm. And the result is this here. It exactly found the title bar. Boom. After making the slices, it does a fine-tuning. It goes pixel by pixel and says, okay, where is the boundary? The whole algorithm is like this function for the exact height, and this function for the slices, for the rough search. Yeah, it's pretty short. And if we flip the screen 180 degrees and do the same algorithm, then we get stuff on the bottom. Then we will find this taskbar. Let's see if that actually works. It's a live demo. You never know. I think it should work. I was wrong, actually. Live bugs. Bugs are great. Watch me code some bugs. I'm not sure if I'm going to edit this. I mean, this is entertainment, right? There we go. It scanned from the bottom with the usual slices method and found exactly the taskbar with no further input. And the point is, if this does not work because the colors are too subtle or something, you can fine-tune it. They're like 2 parameters or whatever. The number of colors, the tolerance, color tolerance, and the height of the slices. It's 2 parameters or something. But it's a very nice and simple algorithm, and it just works for this case. And I'm just one guy, and I just made this thing here for this one case. But if we had a team working on this, we would come up with so many beautiful image recognition algorithms, okay, that are absolutely understandable, that are very flexible. They're also going to be more efficient because neural networks are not very efficient. They're the only thing we have right now, so they are the best. But there's more, and we can do better. And this can be made more efficient because you can fine-tune all the algorithms to whatever you want. More precision or more speed or less memory consumption or whatever. Yeah. Also, you should really check out this operating system because it's really good. Let's see the current number. I want to know how many uses. 633 installations of my operating system. Latest count. Man, I can't wait to do all the innovation I am hoping to do. And maybe make some money on the side. I want to work with graphics guys and UX guys, user interface guys, text people, and general testers. I might not really work with marketing people anymore. I'm not liking the word much anymore. I do marketing. What do you do? It's a black art. I think it's more important to make the actual product than to say I market this. Quality markets itself. Personality is the best marketing. Yeah. I also got down a little bit from the high horse. I always said I would not look at other chatbot engines. I sometimes do, but usually don't. People say, look at this chatbot and that chatbot. I don't care. It's not how creativity works. If you're a musician, you have to listen to the music in your head, not do other music all the time. You have been doing that all your life anyway, I'm sure. But when you want to start making your own music, you listen to your head. Let that music come out. The same is true with programming. So I look at my own ideas. And when I'm satisfied with pursuing my own ideas, or I'm frustrated, or both, I do look at other engines sometimes. Now I'm looking at ChatScript. It's a nice project. I mean, these are the guys who almost won the Turing test, like the closest anybody ever got to that or whatever. Usually the Turing test setups are a bit flawed. But there's nice stuff in here. I mean, and I find out that this guy, the ChatScript guy, has the same criticism that I have with regards to tools that academia offers us, like the Stanford parser, which is a parser for English, but it's only been trained on a newspaper, on the Wall Street Journal. And please raise your hand if you talk exactly like the Wall Street Journal. No hands? No. I don't either. If you don't capitalize letters, then they are confused, and the parser gets confused by short sentences. And even on the Wall Street Journal corpus, the Stanford parser only has an efficiency, or an accuracy, I should say, of 97%. It's not 100. So, and yeah, I have the same criticism. I think these parsers don't work so well. We need a flexible mode of matching. This is getting very technical, whatever. But I do think I'm on the right track. I follow my own ideas, and whenever I validate them later with other people's ideas, they come out favorably. Alright, that's it.